Solutions to the 3.1 through 3.2 review are as follows. I'll cover most of them, but not all. To sketch this thing, I need to first set up a table, and when I set up my table, it allows me to plot at least some key points. I only plotted 2 points, but I could see that my y values are decreasing. Because they are, I know it is a decreasing function. I have a horizontal asymptote on the x-axis, and that's going to be a decay function. Notice x is negative to make it decay. For the next one, though, I've got two things occurring. My function is jumping up by 3, and when I say the function, I mean the focal point. And the function is going to shift to the right 2, which means the focal point and the vertical asymptote. So my original function is this dotted line right here, which is labeled as 2 to the x. Then I'm going to look for the focal point, which is right here, and I box it in at 0, 1. Now that focal point is going to go up 3. So I go up 1, 2, and then 3. And when I am up 3 from 1, I'm sitting at 4. Now this also means that my horizontal asymptote is going to go up 3. It used to sit at 0, now it's sitting at 3. The shift right or left is going to occur here because that's inside the function. So x minus 2 creates a shift toward positive 2. So I'm sitting here originally with my focal point, and I shift over 1, 2 with the focal point. Now I'm sitting not at 0, 4, I'm sitting at 2, 4. I mark that point, I notice where my new asymptote is, and I pass through the focal point coming toward the vertical asymptote. For number 3, the generic equation I needed was A equals P, 1 plus R over N to the NT power. In this case, we're trying to figure out what I initially have to invest. That's letter P, so I'm trying to figure out P. I also know that I had $12,000 after 6 years. That 6 is going to appear as my time right there. I also know the interest rate. It is 5.25%, but I always express it as a decimal. And then finally, the number of years I need when I do this is going to be 12, because they tell me, not number of years, but how often I compound. They tell me compounding is monthly. So this number right here is going to be how often in a year do I compound, and I compound 12 times. That same number is up here, so it's 12 times 6. Then I get out my calculator, and when I do, I figure out that's the amount. When I'm doing half-lives, the half-lives are always going to have 1/2 as your multiplier. That means that you're going to have an initial amount, you're going to have an automatic constant 1/2, the amount of time that the item, the mass, or the quantity is being affected by half-life or being reduced, in this case, is given as 1,000 years. The true half-life is going to be the number underneath. So the time is here on top, the half-life is down below. Do this part on your calculator that's in the box, multiply by 16, and you get your answer of how many grams are left out of the original amount of 16 grams. On the back side, we have the log base 2 of 64, which means what is the power? That's what log means. What is the power 2 is raised to that'll give me 64? And I know that in this case, log base 2 of 64 means that I can take 2 times 2 times 2 times 2, keep doing that 6 times, and I will get 64. Therefore, my answer is 6. Now, the other information I have here is based on change of base. Don't worry about that. That's not going to be on this quiz. For this one right here, we have a valuation of 8, log base 8 of 30. But I notice that a logarithm and an exponential, 8 to a power, are both inverses. Therefore, an inverse of an inverse is always going to be what you started with, which is 30. Therefore, my answer is 30, because this 8 and this log of 8 undo each other. It's very similar to having something like the square root of 2 squared. The square root and the square undo each other, and therefore I end up with what I started with. Well, what we start with here is 30, and then we apply the log to it, and then we use that as an exponent with 8 as the base. The log and the 8 undo each other, therefore I end up with 30. For graphing this one right here, the true graph that you want to end up with is the dark graph right here. When you see log of anything with a negative in front of it, We're talking about a y value that has been flipped across the x-axis. So we have our flip occurring like this. So wherever our focal point is, which ends up being here, we're going to use that as a rotational point. Here's our original function, and we're going to flip that function once we move it up. We're going to have this as our new focal point away from here, and then we add 2 to get to that new location. So I'm sitting here at 1, 0. Now I'm at 1, 3. And the original graph would be right here through it. Because I have a negative right there, then I'm going to be flipping it this way instead. It's like taking your graph and spinning it around that focal point. So these points here end up down here, and these points here end up here. So it's almost like we're rotating around this line right here. For the next one, the natural log of e to the 1/3 is asking what's the power e is raised to. Then I will end up with e to the 1/3, and that power is 1/3. Whenever you ask for a natural log, you're asking what's the power e is raised to give me what is inside right here. And what I have is 1/3 as my power, and that's why it's the answer. Evaluating these two, again, they have inverses. E to a power is the inverse of the natural log of e. Therefore, these two items both disappear. Keep what you started with, you get 8. Evaluating this right here is to evaluate, first of all, the natural log of 1. If you look at your properties of natural logs, which were on your 3.2 page, it's there that the natural log of 1 is 0. The reason why is because the natural log of 1 is asking what's the power or the exponent that e is raised to that will give me 1. And the exponent is e to the 0. So 0 is the answer to this part of the natural log. That's why I have a 0 here. I apologize. Once again, 15 times the natural log of 1. The natural log of 1 is 0. How do I know that? Because the natural log of e is asking what's the power e is raised to. That'll give us 1. That power is e to the 0. Therefore, the natural log of e of 1 is 0. Multiply that by 15, and when I do, 15 times 0 is 0. When I'm doing this problem, I want to notice that there is a 1/6 that is embedded into this problem as a constant right in front. So I have a 1/6 right here, and I'll rewrite this problem as 1/6 natural log of e. I know the natural log of e is equal to 1, therefore 1/6 times 1 is 1/6, and that is my answer. Don't worry about the material that's down here. Going to the domains here, the best thing to do is to graph it, sketch it. Once you sketch it, you'll end up with this as your graph. Or excuse me, you will end up with a shift of 3 to the left. So if I take my natural log graph and I put it here, and then shift that focal point and that asymptote to the left 3, then I will end up with an asymptote now that is sitting at -3, and I have a new focal point which is over 3 from 1, so it's over 1, 2, and 3, and it's sitting at -2. So my new graph sits like this, and I know now that my domain is all real numbers that are bigger than -3, and that's why the answer is all real numbers x greater than -3. You use the same process here. I would recommend on this one that you graph it, and when you do, you'll find out what the domain is. I'm going to leave that one for you to figure it out. The very last one right here, the natural log of x cubed. The key to it is to use your properties of logs and to move that exponent down in front. When you do, which you're allowed to by the power of logs, I'll get 3 natural log of x. When I do that, I have basically taken whatever my natural log height is, and I've multiplied it by 3. So my natural log height is actually sitting right here. And now I'm going to take that height, and I'm going to multiply it by 3, and it's going to go up 1, 2, 3. And I didn't draw this very accurately, but you get an idea that we're going to have a higher graph. However, the graph still has the same horizontal asymptote right here. Therefore, when they ask for the domain, it's the same domain as a log of x graph, and x is greater than 0, and that is my domain. for that problem.